Hello and welcome again to southern Madison County in the state of Kentucky. Today we're going to focus in on the southeast part of the county, and I'll go ahead and zoom to that quadrangle, the Big Hill quadrangle, tile N44 in the GIS site of Kentucky. More specifically, we're going to zoom in even further to Pilot Knob. I've called it that for a very distinctive geographic feature here, and I've sized my scene so that the four water supply reservoirs for the city of Berea, Kentucky are in the scene, and also what we call the pinnacles, with a lot of interesting hiking trails developed up there. In a previous video, we learned how to download a digital elevation model from the USGS, to convert that to a raster, an elevation raster, to symbolize it and add hill shade. Refer to that for details if you've forgotten about that. But here's the raster that's not been symbolized by elevation, and we put in a hill shade and made it part transparent to give us a little bit more of a 3D effect there. Okay, so that's pretty much where we left it off there. Today what I want to do is show you how to estimate hydrology. Before we do that, let's do one more thing with our digital elevation model, or with the surface, and this will be under the spatial analyst tools, under the surface tool set, and we're going to put contour lines in, and my N44 elevation raster will be my input. And my output will be, I'll call it N44 contour, and I'll specify 100. At this scale, a 100-foot contour interval seems to be about right, and so I'll make the contour interval 100. Our map units are feet in the state plane system, and we'll take the defaults for the rest of it. And it's just that simple. I will now turn that off. I've got another one that's symbolized according to the standard routine for symbolizing topographic contour lines, and I've got the contours labeled. In any case, that's all that it needs to do that little operation. The main thing I want to do, in fact, I'm going to turn off the contours to get them out of our way. What we particularly want to do is to model the hydrology, the stream flow patterns, and but first I want to get from the Kentucky GIS site, I need to get ready-made hydrography data. So go to the Kentucky GIS site, search on the term hydrography, and you'll get a list of things, and this is the one you want: high resolution National Hydrography Data Set. We go to the link, which will give you this long list of all the states. Pick the one you want. We are, of course, using Kentucky today. We download the file, and we open it in Windows Explorer. We extract the files and store them in a good location. So that's all we need. You can do that on your own. It's not hard to find. In any case, let's go ahead and turn those on. We've got water bodies, and we've got Jackson County streams and Madison County streams. We don't have Rockcastle County in this scene, so I didn't put that in. You'll probably want to clip out only the few counties that you need for the hydrography data, because this is a very large file and you don't want to try to display the entire state when all you need is a few square miles. We'll also put roads in, and I've already done that. You've done this before in an earlier project. The one thing I did add in was these local roads, because at this scale the local roads are actually kind of needed, because there's some important routes here that don't show up on the state roads, which are few in this particular area. So you may not have these local roads yet, but go ahead and get those if you can. So I'm going to turn those off. That'll be part of the finished product. And in fact, I'm going to turn off the official hydrography data set. We'll compare them later on. So what I want to do now is go here again in the Spatial Analyst tools. I want to go to hydrology, and this is a several step process. I won't show you a bunch of slides about how to do it. There's a lot of good information and good print material on how to do this. First of all, we have to fill our raster. There are a lot of artifacts in digital elevation models, and if we have pits, that is low points in the landscape that aren't actually low points, water goes in but it doesn't come out. So what we do is fill the pits, and so that's our first step, is to fill. We will put as our input the N44 DEM raster. We're going to output, we'll put it here, we'll call it N44 fill, and we save that. That's all we need to do there. So this looks pretty much like an unsymbolized DEM, and in fact that's what it is, except the pits have been filled. The next thing we need to do is figure the flow direction, and that will be here. We use our filled raster as the input for that, and we will call this N44 flow dir. Remember, you got a 13 character limit on most of these rasters, so okay, that's all we need to do. So once again, the flow direction we don't use directly, we use it as an input for the next step. So an arbitrary number indicating compass direction, and a color scheme that's also arbitrary, whether it goes east or southeast or so on and so on up to northeast. Okay, now we use this as the input for our third step, the flow accumulation raster. So here's my flow direction raster, and we'll call this one N44 flow accum, and we'll save that. We'll take the defaults there for data type and input weight, or we'll leave that blank actually. So what the flow accumulation does, it checks every pixel, and it counts every pixel going upstream that ends up in that given pixel. So the farther downstream you go, the more pixels upstream of it eventually empty into that. Now this sure doesn't look like much, but what we're going to do is classify it. And let me get rid of these so we don't confuse ourselves. We don't actually need to use those again. So here's my flow accumulation raster. I'm going to symbolize that. I'm going to classify it. So we'll say classified, and we want to just do 2 classes. And since I've done this before, I kind of know what to expect. And something like 1,000, anything that's 1,000 or less is not a stream, and anything that's greater than 1,000 is a stream. You just have to play around with different data sets and figure out what's best. So if it's not a stream, I want no color. If it is a stream, I want to make some sort of fairly bold blue color to see what that looks like. And there we go. So that's our estimate of stream flow. Let me point out a couple of things before we finish up here. Let's put in our take a look down here in particular at Owsley Fork Reservoir. Since the reservoir itself is flat, once a stream enters the reservoir, the DEM has no information. It really doesn't know what to do with it. If pretty much scoots straight as it can to the exit, and that's obviously unrealistic. What we can, let me show you one other thing. We'll turn off that, and we'll turn on the hydrography data streams. Let me turn off the reservoirs. On the National Hydrography data set, you'll see that they have done an estimated flow according to the original contours underneath the lake. But in any case, that's neither here nor there. We can kind of look and see these don't always match up, but it's pretty close. It's a good estimate of the stream flow pattern. So we can take this raster and make it into a line shape file, a polyline shape file. We can determine pour points, that is where 2 streams come together, and we can estimate the watershed, and it will delineate the watershed. There are a number of different things we could do, but we'll leave that as it is for today. That's enough to give you an idea of how this tool set works. And finally, let me show you kind of one version of the finished product with the roads symbolized nicely, with the contours, with the water courses and reservoirs and so on, and tidal and north arrow and scale bar and so on. So that will be all we'll do for today, and thank you, and I will be in touch again.